Assignment 5, we're going to look at improper integrals. It's important that you've done the homework for section 10.1 because you're going to be checking those answers against those that Mathematica determines. In order to do this, you need to know how to make tables of values in Mathematica. Here's a summary of the commands that we'll be using. And in addition, you also need to know how to take limits in Mathematica, including limits that go to infinity and left and right hand limits. So here are the directions. You can see that I have starred 5 of the problems from this homework assignment. For those 5, and only those 5, I want you to use Mathematica to check your results by following these steps. So you can see I've broken them all down. There are 2 particularly important steps. At step C, what Mathematica gives you should be one of the things you get as you go through doing the work. And then in part G is where you're going to see what the final answer should have been. We're going to go through all these steps together in a demo lab that I've created. All right, for this demo, we're going to look at some of the improper integrals that were in the lesson video that I created. So if you have that page of notes handy, that might be a little bit helpful. In example 3, we were taking a look at this improper integral, which we split up into 2 separate ones. So I'm going to take just this yellow highlighted portion and go through how I would check and see what value this integral should have. Step A says we're supposed to store the integrand as f of x. Again, please make sure you're using the proper syntax for storing a command. And realize that where the dx is, there's also a 1 in that numerator. So my integrand is 1 divided by 1 plus x squared. You do need parentheses around your denominator. The next step, it says, is integrate f of x from the lower limit to the upper limit. One of these should be t. And in the lesson video, you learned that the one that should be replaced with t is the one that is causing a problem for the integral, which is either infinity or a discontinuity. I'm going to put in my integrate command. And inside set brackets, I'm going to say let x go from not 0 to infinity, but 0 to t, and shift enter. Now, you may get a conditional expression here, and you may just get a simple expression. If you get the conditional expression, you're going to take just this first part of it. I'm going to highlight that. And I'm going to paste that into the next one. We're supposed to store the output as capital F of t. And arctan of t should be what you got when you integrated the t integral by hand. In other words, this is the inverse tangent. And if you have your notes, you should be able to see where we got to that step. So I'm going to store, once again, it's capital F, arctan of t. You can ignore the rest of the conditional statement. Next, you're told to make 2 table of values. Now, the table command is a little bit complex. You need to put table form at the beginning so it formats it to look like a table. And then inside the table function is where you give your specifics. So for this lab, you want your x variable to be t, and you're going to want your y variable to be n of f, capital F of t. N is just going to give you the numerical value instead of fractions. So you're going to see decimals in your table. And you will have to choose appropriate values for t. So what I'm saying with this command is I want t to go from 10 to 100 in increments of 10. In other words, it's going to count off 10, 20, 30, 40, 50, 60 up until it gets to 100. Now, why did I choose those values? This integral is supposed to go from 0 to infinity. So I should be choosing positive numbers for my table. And then the last part of the table command is where you put headings on the table. And please again notice the syntax here. You have to do this empty set brackets in the beginning in order for the table to be formatted properly. I hit Shift Enter, you can see what the output looks like. And what you're supposed to be looking for is to see if it looks like these capital F of t values are approaching a limit. Because if so, that's going to be the limit that this integral converges to. Now, after you've made a first table, I want you to make a second table where you have more values so you can see more of a trend. So notice in my table command this time, I said, let's go from 100 to 1,000 by increments of 100. You could even go further. I mean, there's no one right way to do this. But what you can see now is I have more values to look at, and I can see, okay, yeah, this seems to be heading to the number 1.57-ish, which if you have your notes, you know that that's really just pi over 2. So at this point, based on the table, you're going to say, do the capital F of t values appear to be heading towards some value? And you should answer that in text form. If you go back to the menu at the top of the screen, you'll have Format, Style, and you have a text option there. So I'm going to choose that, and I'm going to say yes. They appear to be heading to approximately 1.57. I had to do a little editing here because I had a mistake. But the next command is that we should take the limit of capital F of t as t approaches the integral limit that was changed to t. So for this particular integral, if we go back to the top, we replaced infinity with t. So that's where I'm going to take my limit. Take the limit of capital F of t as t approaches. And to make the approaches symbol, you're just going to use the dash or the subtraction key and a greater than sign. And we want to let it approach infinity, so you can just type in with a capital I, infinity. And it tells you the limit is in fact pi over 2. And again, just to confirm, if you put capital N of pi over 2, you can see that is the decimal 1.5708 approximately. Now I'm going to integrate the original improper integral with the original limits. So I'm going to type in, please integrate the original, which was the lowercase f of x, and let x go from 0 to infinity. And notice we get the same answer. So this was the answer that we came up with for just that one integral as part of example 3. And then the one thing you've got to make sure you do is clear these function names each time, because we're going to be using them repeatedly. So once you do that for the first starred problem, you're going to go ahead and continue to evaluate the other 4 problems that I asked you to look at. All right, so now we're going to go ahead and take a look at example 4, and in yellow here, this was one of the improper integrals in that example, and we're going to go through the steps one more time. So I'll begin by storing my function, which is 1 over x squared, and I need to integrate that from the lower limit to the upper limit, and one of these should be replaced with a t. So I'm going to say integrate my f of x as x goes from, and if you remember this example, it was 0 that caused a discontinuity, so that's where my t should be. So t to 1, shift enter. Okay, now again, in this case, I got a conditional expression, and when that happens, I'm just going to take only the first part and ignore the rest. And this again should be what you got when you integrated the integral by hand. If you have your notes, you can see that that's true. Again, we're going to want to make 2 tables of values. Now this time, our integral is only supposed to go from 0 to 1. So in my first table command, I have t going from 0 to 1 by steps of 0.25 or 1/4. Hit shift enter. we have this statement of complex infinity here at 0 because it's trying to do division by 0, and that's causing a problem. But otherwise, we do get values in our table. To get more values, in this case, I want to stay at 0 to 1, so I just made my increment smaller. And again, there's no right choice for that. Just keep trying until you get something that works. Now you need to remember that in this situation, we replaced the 0 with t, so that's what we're going to be approaching. So when you're reading these two tables, you don't want to be reading them from top down. You actually want to be thinking of starting at 1 and approaching 0. So you can see my values are getting bigger in my capital F of t column. In the next table, again, you can see they're continuing to get bigger and bigger. And again, you can change your increments as many times as you need to convince yourself that, in fact, this one's just increasing without bound. So for this one, I would say, do the capital F of t values appear to be heading towards some value? I'm going to change to text, and I'm going to say, no, the F of t values as t approaches 0 seem to be increasing without bound. All right, now take the limit of f of t as t approaches the integral limit that was changed to t. I'm going to take the limit of capital F of t as t approaches. Now remember, in this case, we replaced t with 0, so we're approaching 0. And I need to give a direction, whether this is a left-hand limit or a right-hand limit. You're going to need one of these approaching arrows. And notice two choices will pop up. My choices are to choose from above or from below. If you watch the video, you know you want to be approaching that t value from within the integral. So we're going from 1, which is a value that's bigger than 0, and approaching 0, which means we're approaching from above. So I will put in from above. And notice we do get infinity. So that confirms that these values really are just increasing without bound. We can go back now and integrate our original integral with the original limits of x going from 0 to 1. You'll get a statement here that says the integral does not converge, which is true. And again, don't forget to clear your functions. So when you submit this lab, you should have done the 5 starred questions that are on your instruction page.